Question 1, part B. Tom takes 5 seconds to retrieve the first stone and place it into the bucket. The time it takes him to place each subsequent stone into the bucket increases by 40%. Now, to increase by 40% is to get 40% of it and add it on to the original 100%, which is the same as multiplying by 104% or multiplying by 1.4. So that's important. So it's the 5 seconds, and then 5 multiplied by the 1.4, and then that multiplied by 1.4, and so on. So this is a sequence that we can look at now, where this is a geometric. And how many stones can he retrieve and place in the bucket in 10 minutes? Well, that's Sn. That's summing up all the time it takes him to retrieve each stone. And because it's a geometric, we use this formula. And I know that that formula in this situation is equal to 10 minutes. Now I need to be careful that I am using the same units. So I can't be 10 seconds here. It has to be, 10 minutes, it has to be 600 seconds. And so it might not exactly be equal to the 600 seconds, but we'll see what n is, as close as possible to that, how many stones he can retrieve in that amount of time. So we have a 1 minus the common ratio is any term divided by the previous term there, which is 1.4 to the power of n. I don't know. Now, usually when I see a missing power, I'm thinking at some point I might have to use logs. So now I can work this out and clean it up, and I'll end up with 5 times 1 minus 1.4 to the power of n all over minus 0.4 is equal to 600, and I can bring this over, it becomes multiply. I can multiply this out on the top, and I'd eventually get 1.4 to the power of n minus a 1 is equal to 48. Now, so that's just working that out. And then we have, that would be 1.4 to the power of n is equal to 49. And I can introduce my logs. Log in the base 1.4 of 49 is equal to n. I'll end up with n is equal to 11.566542. But obviously he can't get 11 and a bit stones and bring them back. So n is 11.